In Activity 8, Electrical Resistance, students examine the flow of an electric current through wires of different thicknesses. Students are first introduced to the concept of resistance, and then predict the relative resistance of two wires. Students finally construct a special circuit with which to examine the relationship between resistance and heat. You will need the following materials from the kit: Activity Sheet 8, Parts A and B, D-cell batteries, battery holders, number 41 flashlight bulbs, bulb holders, electrical clips, 15 cm insulated copper wire pieces, 15 cm number 32 nichrome wire pieces, a roll of number 26 nichrome wire, and wire cutters. To prepare for Session 1, cut one 15 cm piece of number 26 nichrome wire for each team of 2. Make a copy of Activity Sheet 8, Part A for each student. Each team of 2 will need 2 batteries, 2 battery holders, 4 electrical clips, a piece of number 26 nichrome wire, a piece of number 32 nichrome wire, 2 pieces of insulated copper wire, a bulb holder, and a number 41 bulb. To begin Session 1, remind students of their observations in the previous activities by asking, what was the path of the electric current in the liquid conductor circuit and in the solid conductor circuit? Students should recall that the electric current flowed from the negative terminal of the batteries through the conductor back to the positive terminal of the batteries. Encourage students to think about why the bulbs had different brightness in each of these circuits. They should infer that the solid allowed more of the electric current to flow through it than the liquids. Introduce the term resistance to the class as how much a material resists the flow of an electric current. The liquid conductors offered more resistance than the solid conductors, so the current had a harder time flowing through the liquids. As a result, the bulbs were not very bright. Conversely, the solid conductor offered less resistance, therefore the bulb in that circuit received more current and glowed brighter. Explain that nichrome wire is a special type of wire made of nickel and chromium that is used in many small kitchen appliances. Next, distribute the materials to each team and a copy of Activity Sheet 8, Part A, to each student. Allow students time to inspect the 2 pieces of nichrome wire. Then, instruct students to construct their tester. Make sure that they connect the 2 nichrome wires between the batteries and use the copper wires to connect the bulb holder with a number 41 bulb to the batteries. When the bulb lights, ask students, is an electric current flowing through both nichrome wires or just one of the wires? How could you find out? Help students understand that the current is flowing through both wires. If one of the nichrome wires is disconnected, the bulb brightness will change, but the bulb will not go out. Instruct teams to disconnect one end of the thin nichrome wire and write their observations on their activity sheets. Then the team should reconnect the thin wire and disconnect one end of the thick nichrome wire. Ask students which wire offered more resistance. Students should have observed that the thin wire did not let as much electric current through as the thick wire did, and so the bulb in its circuit was dimmer. To conclude Session 1, return all batteries, battery holders, electrical clips, nichrome and insulated copper wires, bulb holders, and bulbs to the kit. To prepare for Session 2, make a copy of Activity Sheet 8, Part B for each student. Each team of 2 will need 2 batteries, 2 battery holders, 4 electrical clips, 1 piece of number 32 nichrome wire, and 1 piece of copper wire. To begin Session 2, review the concept of resistance. Focus the discussion on how the thin wire resisted the flow of electric current, resulting in a dimmer bulb. Ask students, what would happen if you tried to force all the water from a fire hose through a garden hose? Point out that larger diameter hoses permit more water to flow through them than do smaller diameter hoses. Explain that just as we can force more water through a fat hose than a skinny one, we force more electric current through a thick wire than a thin one. Distribute the materials and a copy of Activity Sheet 8, Part B to each student. Then ask students, do you think that an electric current will flow easily through the thin wire? Why or why not? Students should predict that the electric current will not flow easily because the thin wire offers a lot of resistance. Instruct teams to attach the loose wire to the battery and record their observations on their activity sheets. Ask students, what do you think will happen if you force more current to flow through the thin wire? Students may believe that the wire will burst. Have students construct the 2-battery circuit, as shown in Figure 8-2b. Make sure to tell students to not connect the other end of the wire to the battery until you instruct them to do so, as the wires will become too hot. Also, students should be very careful when touching the warm nichrome wire, and touch it lightly with one finger rather than grasp it. Next, ask students, what is the voltage of one battery? What is the voltage of two batteries connected in series? Students should recall that one battery produces 1.5 volts, and that two batteries connected in series produces 3 volts. Then, instruct students to test their circuits and record their observations. Discuss the results and ask, what happened to the wire? Why do you think this happened? Students should respond that the wire got warmer. Help students understand that the more current forced through the high resistance wire, the more heat produced in the wire. Encourage the class to think about what would happen if you kept adding batteries to the thin nichrome wire circuit. Help students understand that the wire would eventually become so hot that it would melt and break. Then ask, in which appliances around your home have you seen red-hot wires? Students may suggest toasters, space heaters, and hair dryers. Explain that because high-resistance wires such as nichrome are able to become quite hot without breaking, they can be used in appliances that help us cook food, get warm, and dry off. Finally, inform students that in the next activity, How Do Bulbs Work?, they will discover how the light bulb works. To conclude Session 2, have students return all batteries, battery holders, electrical clips, and wires to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.